So today's learning goal is really the same learning goal you had yesterday while you were completing, first of all, that guided practice sheet, the check it out problems, and then doing the homework. I can solve equations in one variable. So notice those equations, even though there might have been variables all over the place, it was still just one variable. It was either all x's or they were all a's in that equation or whatever. So there's still only one variable involved, but you had variable terms on both sides, didn't you? So you had to figure out, how do I solve them when there are variable terms on both sides? So this is one of our vocabulary words, identity. It was one of our 9 vocabulary words from the first 5 lessons, which we're now in the 5th lesson. An equation that is always true, this should sound familiar, no matter what value is substituted for the variable. So in other words, it's saying, no matter what you put into that equation for the variable, in all the parts where the variable is, it's going to make that equation true. It's going to check out, basically. So the solution of an identity, then, is the set of all real numbers. We can't begin to name every value. So we have to have a way to say it. So we're going to say it is the set of all real numbers. In other words, it is the whole number line. Every fraction, every decimal, pi, 0, every negative number, every positive number. It is every single number on the number line. How many numbers are there on the number line? A lot. A lot. An infinite number of numbers. In other words, even if you're a whole lot younger than me, neither you or I could ever name every number on the number line before we die. Never. It's not even possible. In fact, you could not even name every number between the number 1 and the number 2 on the number line. You couldn't. Because there's an infinite number of numbers just between numbers 1 and 2. There are so many values. All of those values make an identity true. Every single number on the number line, so we say the set of all real numbers, and here's an abbreviated way. Oh, let me try that again, okay? Let me try that again. It appears that I need to calibrate here. Well, come back, pen. Okay, there's how it is. There's kind of like a double bar off to the side of the R. Is it over there for you to see anywhere? Doesn't look like it. Okay, so this is the mathematical symbol. So instead of having to write all real numbers, you could shortcut it that way. You could just write that capital R with a double bar side. Okay? So when we're solving our equations, sometimes that might be the case. Let's solve 10 minus 5x plus 1 equals 7x plus 11 minus 12x. This should look like something you had from yesterday. Okay? Is this one, should we just dive right in and solve this one? No, we should do some simplifying first, shouldn't we? Are there any like terms on the left side? What are they? The 1 and the 10? Okay, these are constants. They're like terms, aren't they? So we could put them together, and we could rewrite this then as, as 11 minus 5x, right? Could we do that? Equals, how about the other side? Are there any like terms on the other side?
Yes.
Yeah, we have some x's that are like. So we have a 7x and take away a 12x. We can skip over that plus 11 for a little bit. So what is 7x? Take away 12x.
Negative 5x.
Negative 5x. The 11 doesn't have another constant to be combined with, so we'll just bring it down. Do you notice anything about that statement that we have now? That's true.
Both sides the same.
Both sides are really the same, aren't they? They don't look the same at the moment, but could they be rearranged, rewritten, and each expression is really the same thing? So identity, this side is identical to that side. They are exactly the same expression. So at this point, I want you to write that we really have here an identity. You know what? At this point, we could really stop and say, this is an identity. And I already know that an identity has what for a solution? What's the solution for an identity? What does it say up there? All real numbers. We could really stop right here and say, you know what, this is an identity, so I'm going to say all real numbers is the solution, but we're going to keep going because we want to see what will happen. Just in case you don't recognize that, I want you to see what will happen with an identity when you're trying to solve it. So what do you want to what's, you know, what do you want to say would be a good first move to make here now that we're ready to solve it? Trevor?
Add 5x.
Add 5x, okay, so add 5x because it's being subtracted over here, so if you add it, it will get rid of it on that side and we can be over here. Well, over here they do cancel out. We have an 11 left. That's kind of silly. What happened there? We have an 11 left over here. What happens on the other side?
The x.
They cancel out also, don't they? And we get an 11 is what's left. What happened to the variable? Cancel each other out, they're gone. They eliminated. And what's true about this statement? 11 equals 11. What do you want to say about that? True or false? That's true, isn't it? Let's say this is true. You know what? I'm feeling kind of good about that. At least that's a true statement. Well, so this is what should happen when you're solving an identity. Let's write down what should really actually end up happening. The variable eliminates. In other words, it disappears. You can't say, here's what x equals because it's no longer there. It's gone. The variable eliminates. And the resulting statement is true. It's going to be a long sentence. The variable eliminates and the resulting statement is true. Therefore, now, in your homework you don't have to write this out every time, but it's nice to have notes that say, you know what, how did we decide that this is going to be the solution? Because when we were solving it, the variable eliminated, the resulting statement is true, therefore the solution is all real numbers. Instead of being able to say x equals some certain value, I'll put my punctuation right there, it's kind of in the circle there. The solution is all real numbers. So we don't say true for our answer. We don't say it's an identity. We can say all of those things, but that's not really saying what the solution is yet. The solution is all real numbers. So to prove it is an identity, or in other words, for us to, prove that it really fits the definition of an identity. Any value, all values for the variable will make it true. I want you, without looking at, a neighbor's paper, I want you to pick your own value for x, pick your own value from the number line. Be creative, don't everybody use 1 because that's not even a challenge. I want you to pick a value for x, so right here, and I want you to, I'm going to do, let's see, I think I'll do -10. You go ahead, pick your own, you can't have mine. You pick your own value for x, put it in there, here's what you're going to do. You're going to do a check problem. So in other words, you think the solution is whatever you put there, and you're going to check to see if it makes the equation true. Maybe some of you haven't even done a check problem yet this year, I don't know, but hopefully you have. So in other words, you're going to substitute. I'm going to change this first of all, though, to add the opposite. I'm going to make this a lot easier to work with. Add the opposite. And then I'm going to substitute in my value I chose for x, and you're going to substitute in your value you chose for x wherever there is an x in the equation, okay? Anybody unclear what I'm expecting you to do? Need me to help you out? So if you haven't done a check problem yet this year, you might want to open your book and see if that'll help you out. something equal to itself, right? Otherwise it doesn't check out. So anybody get a number to check out? What do you get? Trevor, what's the solution according to you?
I did X equals
100. 100 checks out. How about you, Mitchell?
X equals 5.
X equals 5. 5 checks out. Anybody else got another one that checked out for you? Is that
X equals 6.
X equals 6 checked out? Okay. Anybody else use a negative number like I did? How can we practice those multiplying by negative skills? Huh? What should happen no matter what number you chose? No matter, anybody choose a fraction? No, nobody want to challenge themselves to a fraction. How about a decimal number? No. Anybody use 0? Would all of those ones that you guys chose not to use, would they work? Should they check out? Absolutely they should, because any number we choose from the number line should check. So if you're like, well, how am I going to do a check problem for an identity problem when I say that the solution is all real numbers? Here's what I suggest. Choose a couple of different values. Make sure that at least 2 different ones check, because if at least 2 different ones check, then you can say, oh yeah, this must be an all real number solution one. Because can we begin to check the whole number line? No, we can't live long enough for that either. Okay? So what should happen when you substitute in any number? Because we say the solution set is any number you want on the number line, it should make the equation true. And that's what we found a few values did anyway. Anybody have any questions? So when you're solving these problems, and this happens, what do you put down for the solution? All real numbers. And you can use this symbol if you want. If you want to use this, where did I show that? Oh, it's disappeared here. Oh, it's over here, right? Okay, so the symbol, you could use that instead of writing the words. I'm cool with that. Okay, let's go to the back. So guess what? Some equations are always false. I'm going to calibrate it for a moment. Therefore, some equations do not have a solution. Fill in the blank. Some equations do not have a solution. Because no matter what you do, you cannot find a value for the variable that will make it true. No matter how hard you try. So do not have a solution. Well, let's see what happens in that case then. You go ahead and solve this one because you know how. And if you're, having any trouble, you need some help, just let me know. I'm going to help you out. Otherwise, I'm going to work it on my own here. Everybody gets to do whatever they want with it. It's your, it's your baby. By the way, especially when you're doing multi-step equations like these are, there's lots of first moves you can make. So some of us might make a different first move than somebody else does. We might end up with a different statement than somebody else does. Anybody else have that happen? Anybody else move a constant first? Maybe you added 3 to both sides? Or maybe you added 4 to both sides? Anybody do that instead? You can move the constants first if you want, but you know what, the only thing that sometimes happens is we move the constant, and then we decide, so let's say we added 4 to both sides. I'm just gonna rewrite this again. Hopefully I can give myself enough room here. 13x plus, there must be a way to move this over, plus negative 4. And if I guess I did run out of room. Okay, so plus negative 4. If I'm going to, I say to myself, you know what, I want to get the negative 3 off of that side. I'm going to add 3 to both sides. So now I have 13x equals 13x plus a negative 1. So then the next move I make is I say I'm going to subtract 13x from both sides because, oh, this is an x here. I'm going to subtract 13x from both sides so that I can get that x off of that side. And then this is where students go, then it falls apart for students. They're like, oh no! Well, those cancel each other out, so there's nothing there anymore. And so then I'm going to have, what am I going to do? What will this be? What will the result of that be? What's nothing? What number is nothing on the number line?
0.
0. Is 0 legitimate? Yeah. Don't snub it. It's a number just like your age is a number. 0. This becomes 0. Equals, bring our equal sign down. Those cancel each other out just like these guys did over here, except typically we just don't do this. We don't write 0 plus negative 1 because we know that 0 plus anything is worthless, right? But here it has to take this spot because it didn't have anything else to be added to. What is 0 plus 0? 0. So we're going to say we end up with 0 equals negative 1. Either way, the same result happens. What is true about this result? What is true about this result? True? Are those resulting statements true? No, they are false. That is not true. Negative 3 does not equal negative 4. No way. 0 does not equal negative 1. So what we're going to do is we're going to say in our notes, the variable did the same thing here. It eliminated. So the variable eliminates. Oh, here we'll just say eliminated. The variable eliminated, and the result is false. Therefore, what are we going to say? We got to say something about its solution. What? Yeah, therefore, there is no solution. Our solution is no solution this time. So we would say, here's what happened. We don't have to write all that out, but we would say to ourselves, hey, wait a minute, the variable eliminated. It's no longer there. But I have this statement that's not true, so it can't be an identity. I got a statement that's false, so that tells me, you know what? This is one of those no solution ones. In other words, here's what you can't do to your friends. You cannot just make up an equation, hand it to them to solve, and say to them, you know what? You have to solve this. And you try, and you try, and you try, and no matter what happens, you keep handing it to them, they keep saying, nope, that's not the solution. So finally, you just say, there is no solution to this. And they say, no, there is. I made it up. There has to be. No, it doesn't have to be. It can be a no solution one. You can make up an equation for somebody to solve, and it can have no solution, no matter what. So that would be. Now, let me show you what little symbol you can use for no solution. Here it is. The empty set is called. No solution means there's nothing that satisfies x. There's no value for the variable that will make the equation true. So if you don't want to write the words no solution, you would write that. That's the empty set symbol. Okay? Anybody have any questions on that one? Okay, this next one's kind of like 34 and 36 were in your homework. Set up your own equation and then solve it. Okay? Let's describe our variable. That's, even though this isn't like really an application problem, it's one that we still have to set up our own variable for. So which variable do you want to use, and what would it represent in this situation? Don't make this too hard. This is not a trick question. What don't we know? We know that the number is decreased by 30, but we don't know what the number is, do we? So what do you want to call it? What variable? X, okay. X is the number. Oh my goodness, that was kind of a no-brainer. There we go. X is the number. It's the number that we don't know what it is. They're talking about this number in the problem.
Could I have your attention? We would like to announce our 2016 homecoming royalty. Our queen candidates are Amanda Anderson, Katie Clark, and Haley Peterson. And our king candidates are Nate Rodriguez, Drew Oberlander, and Mikey Meester. Congratulations to all of our royalty. Would all of the homecoming royalty please report to the senior high office immediately, or immediately after school for a picture. Thank you.
Okay, they're probably all gone because they're seniors and they have to study hall, they don't have to be here. But anyway, okay. So, now we're gonna write an equation representing that situation. Go ahead, go for it. Write your equation, see what you get. This is a pretty easy one, just to follow the words, isn't it? Do you agree with me?
That had me next.
Oh yeah, I was, good catch there, Connor. I always use N when you're looking for a number, I don't use X, so that I just automatically, my brain just went there. Thank you, good catch. We only want one variable, and it's not two different kinds of, two variables. Anybody else, anything, think this is a good one now? We have to be really careful that we know, especially with subtraction, that's a tricky one. When they use the word decrease by like this one did and the word minus, they go exactly in the order that it says. Number decreased by 30, x minus 30. If they use the word minus, it goes exactly in that order. 14 minus 3x, 3 times the number. What if they used the words less than though? If they would have said a number less than 30, how would we have written that expression? 30 minus x. So we have to be careful when we're writing these that we know how to remember. We learned way back in lesson 1.1, how do we translate between words in algebra. Okay, go ahead and solve this. If you already have, come on up and do it for me on the board because I'm tired of reading the show off. Let me do it. Go. Doesn't mean we're all going to do it the same way Trevor did, but you know what? Or I saw him getting up, I thought he was. Were you chickening out there for a second?
On the smartboard.
Yep, right on the smartboard. Use your finger. It works better than the pens do. Pens skip for some reason. And the goal is that we all get the same answer. Everybody make the same first move Trevor did? No. Do we have to? No. Absolutely not. What's another first move we could make? We could add 30 to both sides. Okay, what's another first move we could make?
Subtract 14.
Subtract 14 from both sides. Another first move we could have made. Alexis?
Subtract x from both sides.
Subtract x from both sides. All of them should lead us to the same result. We get to decide how we want to do it. First we have to do it so that it'll come up to a good answer. But thank you, Trevor. Anybody agree with him? He says the answer is x equals 11. Yeah, I got some agreeers. He's right. He's right. No matter what our first move was, it should turn out to be x equals 11. Okay, now if you move the 30 first, that was your first move, then I would move the x's on the right side next. I'd move the 3x over to the left side. If you moved the 14 first, then I would move the x that's over on the left side. Get it moved over, and the x would be on the right side, brought together on the right side. If you moved the x first, Then I would take care of moving the 14 that is on the right side, so it comes off the right side and is combined with that last side. So you know what, we just have to make good, wise moves. We're gonna learn how to make good moves on this. Okay? So these are the things that, you know what, if you're not getting them, don't pretend you are. Let's learn how to do them so that we're gonna be able to keep moving on and not be stuck back, not understanding how to do something before. Anybody have any concerns or questions right now? I'll turn the